Bismillah ar-Rahman ar-Rahim. This is our 7th week lecture. So today we are going to cover the repetition structures. We start with the while statement. And the while statement, as I'm just telling you, it is doing a repetition structure. In the repetition structure, the programmer specifies an action to be repeated while some condition remains true. And this condition can be counting. You are counting the elements 10 times, 7 times, 9 times, and so on. Or it can be another condition. So, for example, this is a pseudocode. This is a pseudocode. Pseudocode means it is not a code, but it is just a pseudocode. And this pseudocode saying, while there are more items in my on my shopping list, purchase next item and cross it from my list. So you have list, you have item number 1, item 1, 2, 3, up to 10. Once you finish these 10 items, then you will continue looping, purchasing item and crossing it off the list. And you continue the loop until you cross every single item. And then you return to the normal execution after you finish this looping. So you, in the while loop, you will do the repetition until some condition becomes false. And we have simply we have two simple conditions: one about counting, or something else. Something else. Let us see that your money has been finished. So if you have $50 and you spend like $50 on the item number 6, then you will stop the loop and exit from it. Okay. So this one is this is program. This is a small program, 3 lines of code, and it will do some function. This function is executed. Product equals 2 times older product until you exceed some limit. So at the very beginning, it sets some initial value for the product is equal to 2. And while this variable, so you have product, this is a variable inside your memory. And initially it has a value equal to. And while this product is less than 1,000, so what is the while statement is going to do? It's going to check this condition. So we have brackets, and inside these brackets we write condition, a condition to be checked. And once you check this condition, the conditions is evaluated, and you have either true or false. And if it is true, if the condition is true, then this statement will be executed. If the condition is true. So now the condition is true, then product will equal to 2 times product, it will be 4. Okay. And again, once you finish this statement, you go to its structure. You go to the while again to check the condition one more time. And since the condition is still true, because 4 is less than 1,000, it will make the product equals to 8. And then it returns to the condition again, and the check it will still less 16, and then 32, and then 64, and then 128, 256, 512, and lastly it will reach 1024. And once the product is equal to 1024, it will go and check the condition. It will find the condition is false. Then it will go to the normal execution after the loop has been terminated. So the termination of the loop is decided once your condition turns to be false. So the while statement, it has the following structure. The while statement will have the following structure. Okay, you write while, and then you write a bracket, and here inside you write the condition, and lastly you write here the statement. And you end this statement with semicolon. The while ends here, huh? The while that you started here ends here. Okay. So what is this condition? The condition has only two values, true, which is non-zero, and false, which is zero. Okay. And what about the statement? The statement can be anything. Can be assignment, can be if, can be while, can be switch. Any statement that we have learned can be for, any statement, huh? Any statement can be written in the statement part. Okay. So while condition, and you set, you compute the value for the condition. If it is an expression and it evaluates to non-zero, then it is true. And if it is true, it will execute this statement. Okay. If it is false, it will not execute this statement. Okay. So let me write some condition. Say in x equals 3, and I wrote this code while x is greater than 7, x equals x plus 1. What does this statement do? It does nothing, because the condition from the very beginning will be false. Huh? So since the condition is false, this statement will not be executed. Huh? This statement will not be executed. Why? Because the condition at the very beginning turned to be false. And once the condition is false, then this will not be executed. Okay? Another example. If I said x equal 3, and I said while x is less than 20, x equals x minus x equals x plus 5. This is a normal execution of a while statement. I'm sorry, if there is a semicolon here. This is a normal execution, and you have x in the memory. At the x at the very beginning, it was equal to 3. 3 is less than 20. Then it will make x equal 8, and then it will make x equal 13, and then it will make x equal 18, and then it will make x equal 23. And as you can see, I am crossing out the old value. The old value is not written anymore in the variable that is called x. Okay. And once the x is equal 23, it is not less than 20. Okay. So this is another example. One more example. X equal 3 while x is less than 20. Printf percentage d, and here x plus 5. And what is going to happen here? So the x is equal to 3. X is equal to 3. And here this is the screen to print on. And you check the condition, x is less than 20. You print f x plus 5. You print here 8. Okay. But be careful. Once you print x plus 5 is equal to 8, what is going to happen? You didn't change the x. So the x remains 3 as before. And the condition remains true forever. And you are going to print 8 forever. Okay? And we call this infinite loop. the loop will remain forever. And what happens at the very end? The buffer will be full at the very end. The program will crash at the very end, but after long run, the program will crash. So this is a great issue. You have to write your loops to be finished. So the condition should be set to terminate the loop correctly. Otherwise, the loop will remain forever. So be careful while you are writing loops. Okay. So we have three cases. The first case that you didn't enter the loop from the very beginning. You didn't enter the loop when the condition was false. The second case, we entered the loop and we did some repetitions and then we exited the loop. And the third condition here is that you entered the loop and you couldn't get out of the loop. So you have to be careful while you are writing loops now. Okay. Let us go back again to the slides. Here. Okay. So the loop is grouping some set of instructions. It might not just be one statement increasing the product or adding 5 to the X and so on. You might need to do more than one. It might need to do more than one statement. For example, you'd like to print something and add something and compute some average and do some branching and whatever. Okay. So the body of the loop is not just one statement. It can be a group of instructions. Okay. And we have two ways to terminate the loop. You have two ways, either counter-controlled loop. You have either counter-controlled loop or something called sentinel-controlled loop repetition. When the counter-controlled repetition, it happens when you have some fixed number of iterations. For example, you'd like to compute the average for the student in his performance in this semester, and he has only 7 classes or 6 classes. Then you have, you know exactly how many numbers to be added, right? If you know how many numbers to be added, then this is called the counter-controlled repetition. It is called the counter-controlled repetition. But if you don't know when the termination condition will occur, you ask for it in another way. We call it sentinel controlled loop, used when the number of repetition is not known, but it depends on some condition. And once this condition happens to be true, then you will terminate your loop. Okay. Let us now discuss the essentials of counter controlled loop. First thing, that the name, you have some variable, you call it the the control variable. So this variable will tell you how many times has passed or how many times are remaining in your repetition, and we call it loop counter. And the loop counter is essential in counter controlled repetitions. And again, since it is a variable, you have to set initial value for it. You have to set initial value for it because it is a variable. And you have to do at every step you do the increment or decrement, because you might start from a large number and decrement the value of the loop counter until you finish, or you increment it by the control variable, and you have the condition to test the final value if you still inside the range or you get beyond the range. So this is the essentials for loop counting, for counter controlled loops. For this is example, this is a very good example here. And this example is just counting from 1 to 10. It is just counting from 1 to 10. So what is executing? It starts with counter here is equal to 1. While the counter is less than or equal to 10, it will printf counter, and this is a screen. It will printf here 1, and then increment the counter. This is incrementing the counter. You know, plus counter, it means this is logically, I'm sorry, this is completely equivalent to writing counter equals counter plus 1. Okay. So the variable counter will be now 2, and 2 goes here. It will be less than 10. It prints 2, and so on up to 10. طب why it prints 10? Because you asked for equality. If you asked for less than, it will print until 9. But since you asked for equality, it will print until 10. So the statement, we start with one statement at a time. The statement int counter 1, it will define a variable called counter, and it will give it initial value to be 1. And you define the counters of the type integers. Okay, the counter cannot be float. And you name it counter, and you reserve the space for the memory and set initial value to 1, the same I have told you. Okay, so this is the program. This is the same code we wrote it in the program, and this is the output. I'm just telling you it will be 1 up to 10, and the variable in the memory was changing its value from 1 to 10. So if you remember, I wrote while x less than 20, and I wrote x equal x plus 5. And I wrote a semicolon, and I told you this is the end of the while statement. But here, I wrote two statements. If these two statements are block, that means they should be executed together, then you add curly brace before and curly brace after. And this will be the block that is executed while the condition is still true. And it is safe, it is more safe for you to write the block. Okay, it's more safe. Because if you forget the block, I will write the same thing using without the blocks, and you will find some issue here. Okay? While counter is less than or equal to 10, printf في percentage d counter semicolon, and here I wrote plus counter. Without using the brackets, the curly braces, this will be infinite loop, infinite loop. Why it will be infinite loop? Because the while understands that it ends here, it ends at this semicolon. If you'd like to treat these two statements as one block, then add a curly brace here and another curly brace here. Okay. Then it is more safe for you to write the block. I'm sorry. To write the block, it is more safe for you to write the block to enclose any statements, either one statement or more statement. If it is just one statement, add it inside the block to make sure that the while statement will not go into an infinite loop. Okay. Can we write the code more condensed? Yes. Using this statement plus counter. Plus counter will do two things. It is compound of two things. Here it is increment the counter. Then it check if it is less than or equal to 10. But if you use this, you have to make the counter initially at 0. If you use the while plus counter less than 10, then you have to use initialization value to 0. Because at the very beginning of the condition, it will increment the counter. And now the counter is not 0 anymore, it will be 1. And 1 is less than or equal to 10. And it will printf counter. Okay. So let me ask you one question, then to make sure that you understand what happens. What is the final value for the variable called counter? The counter in this program starts with 0, and it go 1, 2, and so on. What is the final value here that the variable counter reaches at the end of the execution? Can anyone tell us?
10.
No, this is not 10. Who said 10? Omar?
Yes.
Okay, it's not 10. Because if it is still 10, then 10 is still less than or equal to 10. The condition is true, then it will print 10. But what makes this condition false is that the counter should reach the 11 value. If the counter is equal to 11, then this condition is not true and it will not print. Okay. So the initial value for the counter is 0. If you print here at the end, if you write printf counter, it will print 11, by the way. Okay. It will reach 11 occasionally. Okay. You have a question? Did you understand this part? Okay. So the for repetition statement is also used to define a counter controlled loop. It combines three things. It combines the initialization, it combines the condition check, it combines the counter increment. And then what is inside here is the statements that you want to execute. Okay. So the for statement is exactly doing the same story that we have discussed with the while. So the while statement can be used for controlled counter controlled loops, and also the for statement can be used for the counter controlled loops. Okay, fine. So the for statement is written into this way. You have for, which is a keyword, and then you have round braces, and you have must be two semicolons. You have to write these two semicolons. The first 1/3 of the for is the control variable name and the initialization. The second part is the check on the limit. The third part is incrementing the count. Okay. So this is one very typical example for statement. You write for I equals to 1, I is less than or equal to 10, I equals I plus 1. And here you write the body of the be careful, because this statement, it doesn't have semicolon. You don't write I equals I plus 1 semicolon here. Mm. It is just the increment. You don't have to write here a semicolon. So where is the end of the statement? The end of the for statement is the end of the block. And if you, for example, write something like this, for x equals 0, x less than 10, x plus plus, and you put semicolon here, this is called a syntax error. Okay, this is a syntax error. This line will not compile. So okay, sorry, I didn't write this one, but I wrote it this one. So what is going to happen here? What is going to happen? Someone is asking on the code for in the Facebook. Please, someone reply to her, because I don't have time to reply. Okay, someone reply to your friend in the Facebook group. Okay. If you write semicolon here, then this will be infinite. No, it is not infinite loop. I'm sorry, it's not infinite loop. It will do nothing. This statement is doing nothing, by the way. Okay. And that's why, because I told you earlier last lecture that this is called the null statement. That is doing nothing. And this is used for the sleep operations and so on. So this statement means for us, it tells the processor to do nothing. So if you write here x equals, I'm sorry, if you write here printf x, you know what is going to happen? It will print 9 on the screen only once. It will print 9 on the screen only once. Only once. Why? X will be incremented from 0 up to 10, and then it was doing nothing, and it was doing nothing, then it was not printing, and once you finish the loop it will print only once. Okay, this is big issue, huh? You have to be careful. You have to be careful. Okay, so what is the correct thing is to write is like this: for x equals 0, x is less than 10, x plus plus do printf percentage d backslash n comma x and semicolon. Then this statement will be repeated 10 times. This statement will be repeated 10 times, and it will print 0, 1, 2 up to 9. Okay. I hope you understand the difference. So using the curly braces will be more safe for you because you have to identify what is going to be repeated in the block statement. Okay. Okay. Firstly, the loop executes the initialization statement setting I to the 1. After the condition part is executed, the condition is still true, then the body of the loop will be executed. You have a question? You have a question? Omar, please turn the video off, okay? Please. If the condition is true, the body was executed, the control will go to the third part of the statement. After executing the third part, the control goes back to check. After you do this, so the control starts with I equal 1, check is number 2, 3 is the body, 4 is the increment, 5 is the check again. Okay, so the initialization is done only once, and it is you are not going back to this one. Okay. So format is initialization, loop continuation test, increment, and the statement. And the statement is ended by a semicolon. If you would like to make sure that you wrote it correctly, you add it inside a block statement. And here it prints numbers from 1 to 10. This statement is very different from before because here you see that we define the variable counter inside the loop. You have defined the variable that's called counter inside the loop. So you have to be careful. This statement will, if you tried to print the counter outside
هو الدكتور قطع؟
في حاجة غلط ولا ايه؟
لا الدكتور طالع تقريبا هخش تاني.
الدكتور طلع.
هايل.
طب ايه هنطلع احنا كمان ولا ايه؟
صبرك حمدان.
السلام عليكم. معلش حصل بس ايه النت فصلت شويه صغيرين بس رجعنا تاني اهو. سامعني كويس؟
ايوه ايوه يا دكتور.
تمام تمام 100. And then this is a program that is starts is doing the same function, by the way. It is doing the same thing like the while statement, but using for statement. It uses for the printing. It prints from 1 to 10. So this is a comparison between the for repetition statement and the while repetition statement. In the while, you do the initialization before the loop and do the loop continuation test in the middle, and do in the block you are doing the loop body. Okay. For the for statement, you do it differently. You do the initialization in the first third, you do the check in the middle, and you do the increment or the decrement at the last part, and the statement is in the middle here. Okay, so there is one more interesting part here in the for statement is you can do multiple increments, list of variables to be incremented, and you separate them using a comma. And you have multiple of initializations, the list of initializations, and you can separate them also using a comma. So this is very different from the while, because the while, the increment, you can do the two statements in this part separately. Like in here, you can combine the increment statements at the very end of the for statement. Okay. Okay. What about arithmetic expressions? You can do the initialization, loop continuation, and increment can contain arithmetic expressions. It's very natural to see, for example, if you set x equals 2 here, x equal 2 and y equal to 10, for j equal x, what does it mean? It means at the very beginning x equal to 2, then j will be equal to 2. And you said j is less than 4x times y, and then you said j plus equals. Did you see plus equals before? Please don't annotate while I'm using the screen, please. Okay. For j equals 2 and j is less than 80, 80 how much? 80, this is 4 times 2 times 10. Okay, that's the 80. And j plus equals y over x. Y over x is equal 10 over 2 is equal to 5. What is j plus equals 5? This is equivalent to j equals j plus 5. Okay, this is equivalent to this one. The plus equals and the plus operators are just assignment statements. Interestingly, the increment can be negative, and you can decrement the value, not incrementing the value. You can do this. And if the loop continuation test is initially false, then you are not going to execute the body for any time. And the control variable often printed or used inside the loop, but it's not necessary. You don't have to have a control variable, and we call it the sentinel thing. So this is the while statement. It is written the while or for the loop, for the counter controlled loop. You set the counter value, you check the condition, you execute on the true, you increment and go back for check until it becomes false, and then you come out. And this program is just summing the numbers between 2 and it is summing the even numbers from 2 until 100. Okay, so this is the even numbers. This program is trying to sum the even numbers between 2 and 100. Okay, so if you are starting to add even numbers, then you have to do some variable called sum equal to 0 at the very beginning, because this is the value that you are going to print, and you have to set another variable for the value to be added every time. And at the very beginning, number equals 2, initialization with 2, and until the number exceeds 100, you are incrementing every time by 2. You are summing the number to the old sum. So for example, this will start with sum equals this is number, and this is sum equals 0. And then it check if number is less than 100, which is yes, sum equals sum plus number, then sum equals 2. And then it will do what? It will do the increment. The increment will make it 4. And then the 4 is less than, then it will be 6 here. It will add 4 to the 6 and so on until the loop ends. And as you can see, he added here a curly braces, but since you are just doing one statement, these curly braces are not important. These curly braces are not important because it's just one statement. And after the loop terminates, it will print the sum, which is 2,550. The third and the last structure we have is the do while. The do while. The do while statement is a very important statement. It is doing something very similar to the while structure, but checking for the condition at the end. For the while statement, you check the condition at the very beginning, and if the loop continuation test becomes true, then you go and do the statement. But for the do while, you do the statement at least once. You do it at least once. And you check the condition. If the condition is still true, they do the statement one more time. If the condition is still true, they do the statement one more time. So you do the statement until the condition turns false. Or you do the statement until, while the condition is still true. And be careful here because a semicolon comes after the condition, because any statement should have this semicolon, should have this semicolon. Okay. So in the do while statement, you do write do, and then curly braces, and this, and then the while condition, and then add semicolon. Firstly, the body will be executed. Then the condition of the while is tested. If it is true, the control will be transferred to the beginning of the loop. It means there is more iterations to be done. If the condition is false, the control will be transferred to the statement here after the while, after the loop. Okay. For example, if you let initially counter equal to 1, here we have counter, and you set it equal to 1. Do printf counter, then it will print to the screen 1. And then you add 1 to the counter and check if it is less than 10. So it is less than 10, it will print 2, and so on. It will print from 1 to 10. So you can do the printing from 1 to 10 by using the while statement, by using for statement, by using do while statement. It depends on the order of execution. It depends on the order of execution. Okay, this is the third way to do the loop. And this is the flow chart for it. You set some action to be done, and you check the condition. If the condition is true, do it one more time. If it is false, then you exit the loop. Okay? And this is the program that prints the numbers from 1 to 10. This is a program that incrementing the counter from 1 to 11 and prints from 1 to 10. This will be a larger program. This will be a larger program to make sure that you understand the concept very well. And this program is doing what? Is doing the class average program. It is doing the class average program with counter controlled repetition. You have many grades to be averaged and check the average. So if you have many grades to be averaged, then you have to do a counter controlled loop if you know the number of repetitions. Say we have 10 students in our class. Say we have 10 students in our class. Then this is a clear for loop or while with initialization or do while for 10 times. It's up to you to use the correct one. But usually it is much preferable to use the for statement because it sets the initial value and the condition and the increment in one line. Okay, it's very compact to write for statement. Okay, so for every grade you do scanf, you get the grade, you add it to the total, and after you exit the loop, you divide this by 10. Let us go one line at a time and see what's going to happen. How many variables we need? We need the counter because we are using a counter controlled loop. You need one variable to put the grade of the student into. You need another variable for the total, and you need a last variable for the average. Then these are the 4 variables you need for this program. At the very beginning, you don't have any grade, then the total is equal to 0. And you do the for statement from counter equals to 1, and the counter is less than 10, and the counter is equal to counter plus 1. This is to increment. At every step, once you didn't reach, since you didn't reach the last value for the counter, you enter the grade using printf scanf. You print a statement for the user to let him enter the grade, and you scanf this grade, and you add it to the total, and you do this repeatedly 10 times. And once you finished, then you do the averaging. The averaging is doing the total over 10, and lastly you print the average using printf. And here he entered the grade 98, 76, 71, 87, 83, 90, and so on. And the average was, I cannot read it from here, 81. Next time, inshallah, I will go over much more examples. So I will just stop here. Today we discussed the while statement, the for statement, and the do while statements. These are the 3 important statements that are doing the repetition. Inshallah, I will devote the next week completely to do much more examples, maybe like 7 or 10 problems on the looping. But I have to make sure that you understand the concepts, and that's why we stop our lecture here. Okay, so we stop the lecture here, and we will give you much more examples, inshallah, on the next week. And inshallah, our meeting at 9:30 sharp, like we have done today. Okay, do you have any question?
شكرا يا دكتور.
خلاص يعني كده تمام؟
والله تمام يا دكتور.
اوكي تمام يا شباب. طيب بقى في حاجه مهمه، هو الحضور والغياب. مفيش حضور وغياب عشان تبقوا عارفين دلوقتي، انا ما باخدش غياب، بس في نفس الوقت يعني حاولوا تبلغوا زمايلكم، عشان المحاضره انا شايف ان هي مهمه، يعني ما اعرفش مهمه ولا لا، بس انا ببقى شايف كده يعني. فحاولوا على قد ما تقدروا يبقى ايه الحضور احسن من كده شويه. وانا ببقى سعيد جدا لو عندكم اسئله. هحاول اعمل لكم اوفيس اورز برضو على يوم الخميس كده ان شاء الله. نعمل اوفيس اورز فور يعني الناس الانترستد اللي عندهم اسئله. وحاولوا ما تراكموش الحاجات اللي عليكم. انا بحاول ان انا امشي ببطيء، يعني انا كان ممكن بسهوله اخلص السلايدز، بس انا بحاول امشي بطيء متعمد علشان ما يبقاش الكم كتير. انا عارف ان في دكاتره تانيين حتى ما بيعملوش محاضرات خالص، يعني ايه مش بيسجلوا، يعني بيسيبك تعمل المذاكره لوحدك. بس انا يعني بحاول اساعدك على قد ما اقدر. وان شاء الله باذن الله انا قلت للمعيدين ان هم كل السكاشنز لازم تتسجل،